Okay. See how the 2 is on the outside, there's no parentheses around it? Then that's how you're going to tell that it's either going to stretch vertically or compress vertically. It means it's in front, there's no parentheses. If there's parentheses or absolute value, the number is inside the absolute value. So again, you guys, this has either no parentheses or the number's on the outside of the absolute value. If the number's inside the parentheses, so this is outside basically, this is on the inside. So you either have the inside of something, whether that be parentheses or an absolute value. This sits on the outside of something. You either do not have parentheses or you have an absolute value and the number is on the outside. So if your number is greater than 1, it's going to stretch vertically. If your number is between 0 and 1, you guys, even if it's negative, you always make it positive by taking the absolute value. It's going to compress the graph vertically. So if it's a fraction, it's going to be between 0 and 1. It compresses it vertically or it stretches it vertically. Now, if that number's inside, it's the same thing. If it's inside, it compresses the graph horizontally or it stretches horizontally. So if it's inside, it's horizontal. If it's on the outside, it's vertically. And then you have to decide if it's stretched or compressed. So what we're going to do is we're going to look at 4a. Notice there's no parentheses, so this means that it's going to be vertically. So we know it's going to be a vertical. It's either going to be stretched vertically or compressed vertically. The number, so now look you guys, that 2 is greater than 1, so it's going to be stretched vertically. When you go to graph these, you guys, so I don't make the same mistake, we're going to make a table. But I want to show you what I mean by stretched. So I've got my calculator and I fixed it this time. So we're going to graph that parent function again. Okay? So look at the parent function. See, it's not open too wide, but it's opened up, right? Now if I go in and I put in 2x squared and I graph it, remember the first one you see, the first one it graphs is the parent function. The second one is the transformation. Do you see now? See, it's actually, the opening is smaller. So it's being stretched up. So when it's pulled up, it makes it a smaller opening. So what I'm going to do this time is we're going to make a chart because I did a bad job on that last parabola. We're just going to pick random x's. You guys, you know that our x's need to be somewhere between -7 and 7. So if I put, and remember, 7 squared is 49. Can't do that. So we're going to start with, so let's do -1, 0, 1. -1 squared is 1. 1 times 2 is 2. 2 times 0 is 0. 1 times 1 squared is 1. 1 times 2 is 2. We can't do 4, so we're just going to graph this. 1, +2, negative. And so then we can just, it's not going to be perfect, but we can get an idea. You guys, I'm not looking for perfect, but I'm looking for that idea. Okay, so now let's look at 4b. 4b, this number 1/3 of x. See how the 1/3 is inside the absolute value? Again, that 1/3 is inside. So if it's inside, remember what I said, inside, and the absolute value of 1/3 is 1/3, and 1/3 is between 0 and 1, it's going to be stretched horizontally. I'm going to show you what that means. So stretched horizontally. So when it's stretched horizontally, it's actually going to be wider. Again, you guys, guess what we're going to do? Yeah, you're right. we're going to make a little table. Nothing, there's no shame in making a table. I need numbers between -7 and 7 that 3 go into. You guys, 3 goes into 6. So we're going to do -6. We're going to do -3. Let's do 0. Let's do 3. And let's do 6. We're going to pick those because 1/3 of -6. What is 1/3 of -6? -2. The absolute value of -2 is 2. 1/3 of -3 is -1. The absolute value of -1 is 1. 1/3 times 0 is 0. The absolute value of 0 is 0. 1/3 of 3 is 1. The absolute value of 1 is 1. 1/3 of 6, so 1/3 times 6 is 2. The absolute value of 2 is 2. So now we're going to graph it. And you guys, again, I picked these numbers because I knew that I could do those easy and I wouldn't have to worry about decimals. So -6, 2. -6, 2. -3, 1. 0, 0. 3, 1. I graphed it right. 6, 2. You guys, look how big the opening is now compared to the original parent function on the first page of notes that we took. That's what it means by stretched horizontally. See how it made it fatter. Stretch vertically means it makes it elongated, it makes it longer. So we have stretched vertically, we have stretched horizontally. So tonight, we're not going to do the back. I'm going to do that tomorrow. So again, you guys, we have 3 things. We have a dilation, which talks about whether it's stretched vertically, compressed vertically. That's when the number is outside. We have compressed or stretched horizontally. That's when the number's inside parentheses or inside an absolute value. Then we have a reflection. Depends on if the negative's on the outside or the negative's on the inside. Again, you guys, outside or inside a parenthesis. So this is either inside a parenthesis or inside an absolute value. This is on the outside of parenthesis, or there's no parentheses, or it's on the outside of the absolute value. So this H is either inside the absolute value or inside parentheses, or you have something on the outside. So what I want to do, you guys, I think that your last page, your last page doesn't have a back. So let me show you a couple. Let's just do a couple so you guys can see what I'm talking about. So if I gave you this function, okay, what does this do? What is the parent function? So it's going to translate the parent function. And what is the parent function? Let's talk about that. What is the parent function? It's a linear function, so it translates the parent function y equals x. And because I use translation, this is, you can say, down 1 unit. It moves it down 1 unit. Let's do another one. We'll worry about graphing them. Let's just get to see how it translates. Okay, so notice there's no negative. There's nothing like that. And there's nothing on the outside. There's no number in front of the x. So you guys, the stretch would come in front of the x. So there's just this number. So what does this tell you? This translates the parent function. What parent function has y equals x y equals something squared. A quadratic, so it translates the parent function y equals x squared. Okay, so there's nothing in front. There's only something in the parentheses, so since there's only something in the parentheses,